Good morning to all. Myself, Mahalakshmi, Assistant Professor, Department of Computer Applications, Sri Kaleshwari College Autonomous, Sivagasi. Today we are going to discuss about fundamentals of image processing. Then, image processing is one of the vital role in research area. Before we are going to enter the discuss about fundamental steps, we need to know about what is image. Image is a raw data, so that image, using a image acquisition technique, we capture any object converted into a image. Then digital image. What is digital image? The digital image means the pixels, the image contain X and Y axis. So based on this X and Y axis, we convert into a digital images. Here the input is also a digital image. At the same time, we get the output also a digital image. Here is the pixel. What is pixel? A bit of information, a piece of information about our image is called as pixel. Then why we need images? Image restoration, image enhancement, color formation, morphing technologies. So these are the constraints. We need image processing techniques. So this is the basic diagram for image processing techniques. The first technique is start about image acquisition. What is image acquisition? Using any one device, we captured the image and converted the digital formation. It is called as image acquisition. And next step is image enhancement. Then enhancement technique, it helps to improve our quality of the input image. The improvement of the image, it must produce the good accuracy level. Then next step. Then the next step is helps to increase our enhancement. For example, the image it's have more number of noises, much number of noises. So this techniques help to remove the noises and produce the higher accuracy rate. Then next one is, so here in this technique we have fingerprint images. So these fingerprint images helps to capture the correct person, identify the correct human, whether it is correct or not. Then segmentation. What is segmentation? To split up the particular portion of the image, that is called segmentation. So this segmentation is helps in a medical field or else any other agriculture. So this segmentation, based on the segmentation, we identify the affected tissues, affected areas of the given images. Then it's the technique to classify the graph-based directions. So this technique, it's a image how to store in a correct way. Then this is the graph based results. So this technique is used as classification or as clustering techniques. So that final stage we implement this technique to draw our results like graph manner. Then this is a compression of the images. Our generally image is a large volume of data sets. So this large volume of data set, we won't store that same format in our resources like hardware. So that's why we need to reduce the image sizes using image compression techniques. Then this is the color images. So how we segregate the colors, RGB, grayscale, like whatever, how to segregate our image colors from our given input images. So next, what are the areas image processing applied? So these are the basic areas implemented by image processing. First one is image restoration, then image colorization, image enhancement, face reduction, where whenever we use face reduction techniques, that all places implemented image processing algorithms. Then face tracking, then face morphing, fingerprint recognition. Then these are the few examples for applications of image processing. Then why we need image processing applications and complications. Then image is a most complicated, and whether we must need to implement a technique in a research area. Main complexity is large volume of images and clarity of the images. Then this is the camera. Camera means what is meant by camera? In the initial step of the image acquisition and sensing method, we use these type of cameras using to capture the raw image and converted into digital image for our process. So these are the some configurations to capture the images. So these are the processing systems, example for image processors. Thank you.